This next one is a killer, so hang in there. Um, you've got a 5 kilogram box. It's pulled up a rough incline by a force of 50 newtons, and it's pulled 20 meters. The speed of the box in the beginning is 5 meters per second. What is the speed the instant it's traveled 20 meters up the incline? So this is really good because there's actually two works done on my system. There's a work done by the 50 Newton force over here that's pulling the box up. That's positive work. We'll call it maybe F pole. And there's also work done against friction, which of course we're going to expect to come out negative. And what does it do? It changes the kinetic energy. It starts from 5 to this unknown kinetic energy. And it also goes up a hill, so it changes the potential energy. So I'm going to do a lot of this work off this problem because it's just too much to put it in. I'll put the results in later. What's the F? The F pull is pretty easy to get. Give me a second here. Got to pull off this keyboard. So the F pull, the work of the pulling force, well, it's a 50 Newton applied force, and it's applied for 20 meters. So that, let me get, so that is some positive work. The force is in the direction of the displacement. That's easy. Um, so I've got this. The idea is I'm going to get this, and this, and if I can get the change in kinetic energy, I can find the second velocity by using the kinetic energy equation. So let's do the PE, which, like before, I can't find the change in PE unless I find the change in H. So that this H is the hypotenuse, 20 meters, sine of 36.87. So the H, so we're just using trig. The hypotenuse times um, the hypotenuse, which is 20 times the sine of the angle. This turns out to be 12 meters. That's going to help me find my change in PE. Again, I'll do it off to the side. Change in PE equals mg delta H. The m is 5. 5 times 10 is 50 newtons times the 12 meters. That's 60 joules of increase in potential energy. So now I've got that. Work done against friction equals the mu times normal times the d. The mu is given as mu is 0.10. The normal force is mg cosine theta, that's 50 newtons, mg, because it's on a ramp, cosine of 36.87, mg cosine theta, times the distance, which is given here. The distance that friction acts is 20 meters. So we get about 80 joules, and that's negative work. This work is negative because the force is acting exactly opposite the direction of motion. So now I have all three, and if I can get that change in kinetic energy, I could find that velocity at the top. So let's come down here and say the pulling work is 1,000 joules. Oops, plus the negative work of friction, which is, or minus negative 80 joules, equals the change in kinetic energy, which I'd love to find, plus the change in PE, which I have found as positive 60. Right here is my positive 60 joules. So this is 920 joules equals change in KE plus 60. I'm going to subtract the 60 from both sides. Actually, wait a second. Hold on. I think actually I made a mistake. Yeah, this is actually 600. This is not 60, excuse me. So that's 600. So I've got to change this. That I did the math wrong. 50 times 12 is not 60, but 600. So now I subtract. Uh, Okay, so I subtract 600 from both sides of the equation. I get 320 joules equals change of KE. Okay, 6 it right. And then I'd say 320 joules 320 joules equals 1 half m 5 kg times Vf squared minus Vi squared. So it's 320 joules equals 1 half 5.0 kg times what's the final? We don't know the final squared, but the initial is 5, so that's minus 25. That's that squared. So let's see. I've got to find out what that is. Divide both sides by 2.5. So 320 divided by 2.5 equals 128 equals Vf squared minus 25. Add 25 to both sides plus 25 to get the Vf squared alone. Take the square root, and Vf, this is really nasty, is 12 point, with three significant, we'll call it 12 meters per second. So this was an interesting problem because there were two works done, and so it ends up faster because of this work. You had two works done. The positive work, the pulling force, was greater than the negative work, so we're going to get a net increase of energy. There are two energy increases. It changed kinetic energy because it's had two velocities. It went up higher on the ramp, so it changed potential energy, and there you go. So you substitute it in, and you get the answer. That is quite a nasty problem, isn't it?